This video is for CAM project number 1, and we are going to cover creating programs to start cutting essentially. So once we have our setup and we have our tool library or the tools inserted in our tool library, we can start creating um, our operations. Now, there are 2D operations as indicated by this toolbar. As you can see here, there's quite a few different options. I absolutely encourage you to get a better understanding of what all these do, because there are times where you will want to use some of these, especially engrave is a very popular one to use with a V-shaped bit. Facing is something that we will do, and it's something you need to know how to do to whether you're leveling spoil boards or you want to take down the top face of the stock you're working with. Face is also very important. Pockets, contours are different things we'll use a lot. And then you can get into 3D when you get a little bit more advanced. And as you can see, these are all three-dimensional machining operations. Right now, we're going to be worrying about two-dimensional. Now, um, there's a lot of different ways to create effective tool paths to machine the area in and around the letters. I personally like the adaptive clearing. So that's what we're going to use right now. So let's go ahead and select adaptive clearing, and you'll notice that the toolbar on the right pops up. This is how essentially all the toolbars, or excuse me, all the machining operations, they all look like the same toolbar setup. Now, the first thing you want to do is select your tool. Now, for the adaptive clearing, this is a 1/8 end mill. So if I go to my local library, it's already in here, and I did set it as tool number 2. So I'm going to select that and then come down to the bottom right, click. The only change here is I don't have coolant, so I'm going to disable that. And I can actually set that in the tool library itself. It imported my desired feed rates, so I don't have to change any of this, which I definitely recommend that, especially if you're working with pretty consistent materials, is set all these rates. And I generally just set my feed per tooth and my feed per revolution in RPM, and then I get the surface feet per minute that I'm looking for, surface inches. Okay, so if we go to the second tab here, this is geometry. This is asking me what I want to machine. Well, this is what I want to machine. I want to machine that top surface. I want to machine these inside areas in the letters. A lot of times you got to be patient with Fusion. It does take a few minutes generally. So that's what I want to machine with this operation. Now, the nice thing about Fusion is if you hover your cursor over these, most of these, it will explain to you what exactly they do. And you're going to want to get really familiar with what these do, because in more complex operations, you're going to have to use some of these, especially rest machining. If you're doing something very large, you can really cut down your time by starting with large bits and then moving to smaller bits for the more higher detail areas. Heights is where we generally set the parameters for how deep we're cutting. As you'll notice here, there are essentially 3 planes that have been set. And if I kind of scroll to the top, you can see it's color-coded what those planes are for. The top plane is really important because it is the top of our model. And as long as you have set your material to the right thickness, the top should be at the very top, and it should be the same once you load it into your CNC machine. But if there's been any corrections, you're going to want to make sure that you understand that going forward. What's really important is our bottom height. A lot of times will use the selection option, so I can select exactly which plane that I'm machining to, which obviously is going to be this plane. Now you can see the bottom is now present, and it is saying essentially minus 0.2 inches from the top, or the zero height. And generally, we always treat the top of our material, the top of our stock, as 0. That is pretty much industry standard. And if you ask me, it's the easiest. Anything that is positive is above the material, and anything that's negative is into the material. So it's a really clear way of organizing your depths. Now, don't hit OK yet. We want to get through all these tabs before we hit OK. Now for passes, you can see right here I have something in red, my optimal load. There's an error there. My optimal load is essentially how big of a cut I want to take. Well, I can't take a 0.375 cut with a 0.125 bit. And it even kind of explains this here. Optimal load must be less than the tool diameter. Well, I'm going to take about half the tool diameter is all I'm comfortable with a pretty thin bit. So I'm going to take essentially 0.6. Let's say 6.2 will be right on half the bit, or 0.62, excuse me. So it's right about a 1/16 of an inch cut on an 1/8 bit. I'm comfortable with that. Minimum cutting radius is something where if you don't feel like you're getting the detail in your corners, you can adjust the minimum cutting radius. But essentially, if the diameter of my bit is 1/8 of an inch, my standard cutting radius would be half that. So I feel like with that small bit, I'm going to get enough detail. I'm just going to leave it essentially at the radius of 0.62. Now you can go smaller and it'll get a little deeper into those corners, but that's something you really have to play with. The simulation can help determine what works the best. But to get into corners, you either have to go smaller bit or you have to cut deeper into that radius, but then you can kind of get a rounded look. So you really have to play with that. When you're cutting small details, slot clearing sometimes can be something that helps. Stock to leave, if I'm going to do a finishing pass or if I want to leave a little extra material to do some sanding work, I can do that. I'm not going to be doing that for this. As you can see here, there's some options of multiple depths, smoothing, feed optimization. Again, feel free to explore this and really look at how these will impact your cuts. But for simplicity's sake, for this very simple project, we're not going to be using these options here. Now, anytime we're using the CNC, generally the climb cut is what you want to be doing. That's the type of milling that we're doing. There are times maybe where you want to use a conventional, but for the most part, just keep it climb with the CNC. This last box here, the ramp can be a really good way to get depth. You can see that there are some different options on how it works. A plunge just goes straight down. A helix, essentially, when it's going to its depth, it's going to do little circles. I prefer helix, but sometimes if you're working in a very small area, it doesn't have enough room to do a helix, so you have to do a plunge. So if you're getting errors later on, this is one of the areas a lot of times that you have to change this, and then it will create code. Okay. I'm going to leave the defaults here for now, but this is definitely one area that you can come back with and play with to see how it impacts your program. Now it's going to take a minute for the computer to create the toolpath, and you see that the toolpaths kind of pop up. You will get a percentage here, and now it is good to go. So this is a really good demonstration of the toolpaths. Also, look, you can zoom in and kind of see, are you getting all the detail that you want? The curves would be not a problem whatsoever, but maybe in the N's and the Z's, you can kind of see the limits of where we're cutting here. So if I want to get a more pronounced corner in here, I have a couple options. I can go back and I can change that minimum cutting radius. I can come back with maybe a smaller diameter tool bit. Those are probably the two primary strategies that you could use to do this. But for me, okay, for this, essentially this first CAM project, I'm okay with this. All right, now the next video, we'll talk about the contour. Let's go ahead and check that out next.